Buddy, and welcome to today's episode of In the Life of a Dancer. Today, we'll be incorporating science to show you Alex being picked up for dance class. You ready? Okay, here we go. Whoa! Did you hear that? The frequency of the car horn changed as Lucy was driving past me. You know what that's called? The Doppler effect. The Doppler effect is the change in frequency, a perceived change in frequency, due to the waves being compressed as an object moves past. So, as we all know, the frequency of a standard car horn is 380 hertz. So, to calculate the frequency that I just heard, we take that 380 and multiply it by 1 over 1 minus the velocity of the source, which is the car, which is about 5 miles an hour, over the velocity of me, which is 0. Science is great, isn't it?
So we were on our way to dance class when we decided to stop by the park. Now we're jumping on a modified version of a trampoline. The spring scale constant of it is 365 newtons per meter, and Alex weighs 125 pounds. If you convert that to kilograms, then you can find the oscillation period. Yay. So there you go. To find the period of the spring that Alex was jumping on, we can use the equation period equals 2 pi times the square root of the mass over the spring constant. We know the spring constant and we know the mass, therefore we can plug it into the equation and get the period. So we decided to take an acrobatics dance class, and so we decided to work on our gracefulness swinging on a rope from a tree. And we know that the length of the rope is 12 feet, and if you convert that to meters, you have the length of the string. So Alex is curious to know what the period of her pendulum is. So using the equation period equals 2 pi times the square root of length over g, you know the length and you know g, therefore you can find the period of Alex's oscillation.
So we finally arrived at the dance studio where the speaker produces 300 watts. Now, being the curious little creatures we are, we wanted to know what sound intensity that is. So what you can do is take the 300 watts, plug it into your intensity equation, and then take that and plug it into the decibel equation over the threshold of human hearing, multiplied by 10, and then find the log of that, and you can find how many decibels you get. Here is Lucy at the dance studio practicing, and there is the speaker several feet away. Cool how you can find the sound intensity that Lucy is hearing, huh? Hey everyone! So for our last episode of In the Life of a Dancer, we're going to demonstrate the Doppler effect one more time. This time, we're demonstrating Lucy driving away, meaning the observer is stationary and the source is moving away. Let's watch. First she's coming towards, and there she is going away. Awesome, huh? So we could take the 380 hertz, which is the hertz of a standard car horn, and to find the frequency that I just heard, you'd multiply that times 1 over 1 plus the velocity of the source, 5 miles an hour, over my velocity, 0.
So using we decided to take an acrobatics dance, okay.